This video is to demonstrate how to perform stepwise regression in Data Analysis Plus on Windows operating system. First of all, you have to make sure that you activate Data Analysis and Data Analysis Plus. Now, we start to perform stepwise regression. I put my cursor outside the data range. I go to Add-ins, Data Analysis Plus, and then stepwise regression. I get a warning message. The cursor must be positioned somewhere within the dataset. Okay, I quit. I move the cursor inside the dataset. We do the analysis. Okay. Oh, there's another problem. We need to choose the names carefully. We cannot have x1, x2, etc. because the name is identical to the name of the columns in Excel spreadsheet. So let's rename our variables. For example, the variables are underscore y1, underscore x1, etc. Now, move the cursor into the dataset. We do the analysis, Data Analysis Plus, stepwise regression. Okay, once you get this page, it means that everything is fine. Choose the response variable y, choose the independent variable x1 to x6. Just keep going. Now, this is the output from stepwise regression. First of all, x2 is chosen to be the most important independent variable. And then x1 is the second most important independent variable. And x3 is the third most important independent variables. And no more. So stepwise regression gives us this summary table. x1, x2, and x3 are chosen to be the most important three variables to be included into the regression model. Now, what we need to do is to perform regression analysis on x1, x2, and x3. I would suggest you to copy the data into other columns. The reason is that suppose that x1, x3, and x5 are the most important variables, you cannot run regression analysis by choosing x1, x3, and x5 as your independent variable from the original dataset. So I would suggest you copy y, x1, x3, and x5, these four columns somewhere else, and then we do the analysis again. Now, I have run regression analysis on a full model and a reduced model. The full model contains all 6 independent variables, x1 up to x6. This model accounts for 72.73% of the total variation in the y values. I have the ANOVA table for this full model. Okay, and now I run regression analysis on x1, x2, and x3. I have the result for the reduced model. Okay, now the 3 independent variables x1, x2, and x3 can account for 71.01% of the total variation of y. Now, what we need to do next is a testing hypothesis. We need to choose between the full model and the reduced model. So we need to calculate the parcel F. Okay. Now, to calculate the parcel F, we need to calculate the total sum of squares that can be explained by the 3 unimportant independent variables, x4, x5, and x6. And they are the difference between these two sum of squares. Okay. And then on average, for each of these unimportant variable, the sum of squares can be accounted for by each of them is the difference divided by 3. Okay. And now, this value divided by the mean square error under the full model, and this is the parcel F. And the parcel F is calculated to be 1.33. On the right-hand side of the Partial F is the p-value of this testing hypothesis in choosing between the full model and the reduced model. Now, because the p-value is greater than 0.05, we do not reject the null hypothesis. And the null hypothesis is to say that beta 4, beta 5, and beta 6 can be 0. Okay, so it means that under the null hypothesis, we will choose the reduced model. And the p-value is in the non-rejection region, so we choose the reduced model. Or we can compare the partial F with the critical value. The critical value is calculated from F dot inverse. On the left-hand side of this critical value is 0.95, and the degrees freedoms are 3 and 63, and the critical value is 2.75. And partial F 1.33 is on the left-hand side of 2.75. We do not reject the null hypothesis, and the data are in favor of the reduced model.